The Indian Space Research Organization, ISRO, has played a significant role in establishing a strong communication infrastructure within the country. Today, it is estimated that internet users in India have nearly reached 450 million. Considering India's highly diverse geophysical and climatic features, the provision of broadband connectivity to every part of this vast country through satellites has become a necessity. In today's world, satellite-based broadband connectivity that combines voice, data and video streaming holds immense potential and will be a game changer.
GSAT-11 spacecraft is an advanced communication satellite providing high-throughput payloads in Ku bands. It is the largest and heaviest satellite ever built by ISRO. This satellite will meet most of the requirements of providing broadband connectivity to rural and inaccessible Gram Panchayats under BharatNet project, which is part of the Digital India program initiative of Government of India.
With India moving fast to implement the concept of smart villages and cities, they can be efficiently linked through a large communication satellite.
GSAT-11, weighing about 5,854 kg, is a multi-spot beam satellite providing coverage of Indian mainland and nearby islands. GSAT-11 is the heaviest satellite built by ISRO with the largest solar panels and payload panels. This satellite is also configured with maximum communication antenna 5 numbers in INSAT GSAT family of satellites.
It has mission life of about 15 years. It will enable broadband, telecommunication and multimedia solutions to households, businesses and public organizations. The satellite will also enable next generation applications such as in-flight connectivity. It is India's first large high-throughput satellite and is configured on ISRO's newly developed I-6K bus. GSAT-11 satellite bus is very versatile with separate modules like mainframe system, payload systems and propulsion systems, providing high level of flexibility and ease in assembly and checkout operations. It is capable of supporting a lift-off mass of up to 6 tons. The I-6K bus also has a capacity to generate and handle up to 20 kilowatt of power.
The payload has around 600 subsystems. Nearly 90% of the hardware has been realized in India with extensive participation of the industry. Most of the hardware is miniaturized using advanced MMIC technologies. For the first time, multi-port amplifier is used for power sharing across the beams under varying service demands.
GSAT-11 will be located at 74 degrees east with a multi-spot beam antenna coverage. It will generate 32 user spot beams in Ku band, 16 each in both vertical and horizontal polarizations, covering Indian mainland as well as islands. This will also generate 8 hub beams, 4 in each polarization, operating in Ka band frequencies. The 4 ground gateways or hubs located in different regions will connect the satellite to the users. All the hub stations in turn are connected to each other via optical fiber network, thus creating seamless connectivity.
The satellite will provide a throughput of 16 gigabits per second through 32 narrow user beams for supporting high data rate services across the country. As the high throughput technology and use of Ka band is being introduced in the country for the first time through indigenous satellites, the associated ground hardware are being established by ISRO. The satellite has completed the launch campaign activities and is ready for launch on board Ariane 5 launch vehicle.
GSAT-11 is all set to begin its journey to space in the European Ariane 5 launch vehicle from Kourou, French Guiana. after reaching the preliminary geosynchronous transfer orbit on board Ariane 5. The satellite will be taken to its final geostationary orbital location by firing its propulsion system in steps. Once this big bird reaches the final orbit, satellite-based broadband services will become a reality in India and will significantly contribute towards bridging the digital divide between the urban and rural India.